All right, hello, my wonderful students. This is part 2 of Foldable number 1. For this one, we're going to be simplifying the expressions with the radicals again. And we have two methods here. That's why this is written down twice. We're also going to do two methods on this one. But I wanted to show you one method first, and then there's a second method to see which way you actually want to do it. And it is your choice when it comes to how we're going to actually do it during quizzes and exams. But I want to give you both methods so you can kind of figure out which way you prefer. So the first one is, of course, to change this to our radical expressions. So instead of having 7 to the 1/2 power times 7 to the 1/2 power, we can actually change this as radical 7, or the square root 7, because it's the square root of 7. Because if you look at the from what we had above, you can see that we had the I guess I can write that over here, but let me finish writing this real quick so I know how much space we have. Okay, and we can go ahead and rewrite the thing that we had over here, like on the flip side. When we have this over here, we have the nth root of x is equal to the x to the nth root, which is what we have here. We have x to the nth root, or 1 over n, or up here, sorry, and then we can go ahead and change it to this. So this is the first way. So we already done this before. We know this ends up being equal to the square root of 7 squared. These actually reduce here, leaving us just with our number 7, which is our answer, as well as the second method. So this was the first method. Go ahead and write this in red. So method 1, and this is going to be method 2. All right, the second method, I'll go ahead and do it in green. This one, we kind of leave this as is, and then we use the expression for multiplying exponential values. So we're actually going to have 7, which this only works, remember, if it's the same base. This ends up being 7 to the 1/2 plus 1/2. And this is going to equal 7 to the 1/2 plus 1/2 is 2/2, which is equal to 7 over 1, which is just 7. So we still derive to the same number, so it's just whichever way you feel comfortable to doing this one. All right, going to this one over here now, we have our 3 to the 1/2 times our 75 to the 1/2 power. So we would go ahead and turn these into method 1 like we did. So we go ahead and write method 1 up here. I might actually not even do method 2, but just to show you the method 1. All right, so once again, we'll do this one in blue. So the first thing to do would be turning both into the square roots. So 3 to the 1/2 would be the square root of 3, because it would be invisible 2 here, times the square root of 75, which you're already done. A little side work for this one, we'd have to turn our 75 into our 25 times 3, and then our 5 times 5. That being said, this will turn into radical 3. We can actually put it into the same thing, and then we have 1, 2, 3 here that we're going to multiply by. So 3, 5, and 5. This would give us the 75 that we had here. So we just put it all under the same square root. Then we have our 3 squared times our 5 squared. These all reduce out of the square root, and we're left with 3 times 5, which is equal to 15. I'll go ahead and show you method 2. So I'm just going to call it M2. So I had that space. Because it's a little bit more, I wouldn't say difficult, but definitely a little bit more writing for this one. So for this one, we have, or at least in this case, it doesn't always work out that way. We have 3 to the 1/2 times 75 to the 1/2. We're also going to break down this 75 because we're trying to get our primes just like we did here. So our 75 is going to be 25 times 3. So I'm going to do 3, but in parentheses. So this is a side note, remember. We should probably do this in a different color then. Side note. So it would be 3 times 25, but we got to keep it to the 1/2 power because this is still going to equal to 75. But then if I do distribution, I can do 3 to the 1/2 times 25 to the 1/2 because we just distribute this here. Once again, from here, I say this is 5 times 5 to the 1/2 power. And now we have our, when I distribute these as well, we have our 5 to the 1/2 times our 5 to the 1/2. And now we have our 1, 2, 3, and 4 that way, because this broke down into all three of these. So this is going to be 3 to the 1/2 for the first one times 3 to the 1/2 for the second one times 5 to the 1/2 for this one, and the last 5 to the 1/2. Go ahead and do this just so we see that this is something, the side work. And now we just have to just kind of add each one. So we add these two because they have the same base now. So these are going to be the same base. So we have 3 to the 1/2 plus 1/2. And then we have our base 5 here, which is going to be 5 to the 1/2 plus 1/2, giving us 3 to the 1 plus 1 is 2 over 2, which is 1, times 5 to the 2 over 2. This is going to give us 3 to the first power, which is 3, times 5 to the first power, which is 5. And this is still going to equal 15. So they're both, you get to the same thing. It just depends on which way you want to do it. Doing things like this, I believe if you have to simplify the radical, it's always easier to go with method 1. But, you know, everybody thinks differently. Sometimes this is easier depending on the certain problem or situation.